So welcome to Principles of Engineering course. So today we are going to discuss Unit 4. So these are the course outcomes. So these are syllabus for Unit 4, that is Mathematics in Engineering. So first we are going to discuss linear models, and then non-linear models, and then polynomial functions, and then stopping sight distance, then followed by deflection of beam, and finally exponential and logarithmic models, and solution for simultaneous and linear equations. So these are the textbook and reference book. So in general, engineering problems are mathematical models of physical situation. So what is a physical situation? So the real time situation. Say for example, if you want to measure the heat, so we have to use the temperature scale. Okay. So to measure the heat, we need temperature scale. Okay. So likewise, there are different scenarios that we call it as physical situation. Okay. So all physical situations can be expressed as mathematical equations. Mathematical equations. Set of mathematical equations with input and output could be called as mathematical model. Okay. So what is the model? It has defined limit input and it has a defined range. Okay, input and output have set of values. Okay, that is a model. Okay, so that mimics the real world scenario. Okay, so there are different types of model is there. So mathematical model is one of the one such that in that two basic different types is one is linear, another one is linear mathematical model, another one is non-linear. Okay, linear means following a line, following a line. Okay, and the trend is following line. But non-linear, say for example here y is increasing, x is also increasing. Okay, so here x is increasing, y is also increasing. This is linear. In case of non-linear, this is not the case. This will be like this. Okay, so the wave, there is a different type of waveform, so it can follow any non-linear type. Okay, so there are different type of non-linear curves. One is plane, B-spline, polynomial, non-linear, rational B-spline, that is called a NURBS. So there are different type of non-linear waveforms possible. Okay, so these are going to be applied in our engineering problems. Okay, most of the engineering problems we deal with the mathematical equation. Okay, so that is so these are the symbols, the basic symbols you refer, and these are the Greek symbols. So we often use to represent the physical entities. Say for example, psi, where the psi is used. So psi, where it is used? Schrodinger wave equation. Okay, you know Schrodinger wave equation. So there they use the symbol psi. So what is the Schrodinger equation? So previously in the Newtonian era, everything is particle. In the quantum era, everything is wave. Okay, everything is a combination of particle as well as wave. Okay, sometimes it is behaving wave, sometimes it is behaving like a particle. So for example, if you take electron, which is circulating around a nucleus, it is moving like a waveform. This is called a wave equation. Okay, it's called wave equation, called a psi. Likewise, there are different symbols we use. Okay, tau is used for stress, shear stress especially, sigma for stress, rho for density, and the pi you know already 3.14. So there are a number of symbols. Okay. Next, Roman numerals. Roman numerals. You just refer everything. Next, linear models. Okay, so we are going to discuss about linear models. These are the simplest form of equations commonly used to describe a wide range of engineering solution. If you increase the stress, automatically what happens? The body will deform. If you apply force, what will happen? The body will deform. deform. How much the deformation? It purely depends on the force. This is called a linear problem. If you increase the force, the deformation level also increasing. The deformation level also increasing. It is following a linear trend. It follows a linear trend. Okay, so that we call it as linear model. Okay, if you express them as a mathematical equation, that is called a linear model. Okay, understand? So this is an example of linear model that already we discussed. So if you increase the force, then automatically the x will increase. If you increase the force, the deformation will be increased. If you decrease the force, automatically deformation will be reduced. Okay, decreased. So this is an example for linear problem. Okay, next. So there are dependent variables and the independent variables. So the simple thing is dependent variable means, so variables here two types. One is dependent and independent. Okay, independent. So dependent means that this is the output. Simply it is output variable. This is input. So which one we can change independently? Input can be changed. Okay, input can be changed, but output we can measure. Okay, output can be measured based on the input. So output is based on what? Output is dependent on input. Output is dependent on input. Input can be changed. Say for example, if you grow a plant, okay, if you grow a plant, so there are different variables. So exposure to sunlight, so this is a variable, and the amount of water present in the mug, that is another variable. If you reduce the variable to 0, if you reduce the water level to 0, then what happens? Even if it is exposed to 100% to sunlight, what happens? We are only providing one variable and cut the entire variable. So there is no way to grow the plant. Okay. So here the height is a dependent variable. Height is a dependent. Okay, dependent variable. Which one is independent? Which one we can measure? We can change is a dependent variable. Which one we can change is a independent variable. Say I can increase the water level or decrease the water level. Okay, so that is a independent or dependent variable. So I can reduce the water level or increase the water level. Is it a dependent variable or independent variable? It is a independent variable. We can change. Whatever we can change is a independent variable. Okay, input can be changed often. So it is a independent variable. So the height of the plant is purely dependent on these factors. So that is why it is called a dependent variable. That is why it is called dependent variable. Okay. Similarly, here if you take the spring, when you stretch more, when you supply more force, then automatically the stretching level will be high. F is increasing, X also increasing. F is increasing, X also. What is X? X is the deflection. How much the spring is deformed. That is the X. Okay. If you increase the force, then automatically X will be increasing. X also increasing. This is an example for linear model. So in that you plot a graph. Okay. Already you plot a graph. There is an activity regarding. So this is the graph you achieved. Okay. In the previous class. So this is the next activity. I am configuring it in Moodle. You just try to answer the problem in the Moodle. Okay. I am giving it as a Moodle activity. So you have to find out the. So next linear equation. Next topic is linear equations and slope. So usually we write like y equal to mx plus c. Okay. So m is a delta y by delta x. C is y intercept. Okay. So c is y intercept at the point at which the line is touching. So likewise you plot the temperature Fahrenheit versus Celsius. Okay. So you take this as the degree Fahrenheit and this as degree Celsius. This is activity for you. Okay. This is an activity. Please note it down. You plot the line for degree Fahrenheit and degree Celsius. Take different values of the degree Celsius. Calculate degree Fahrenheit and plot it in a XY plane. Okay. So next there is a Moodle activity. So for each one there is a equation for which you have to calculate the slope. Okay, for which you have to calculate the slope. You find out, you plot and find out. Okay, so complete this in Moodle. Okay. So shall I move to the next topic? So what is this? Degree Celsius. Okay. So you just put 0. What happens? If you put 0, then what is degree Fahrenheit? 9 by 5 into 0 becomes 0 plus 32. So at 0 degree Celsius is equal to 32 degree Fahrenheit. Okay. 32 degree Fahrenheit. Where? At 0 degree Celsius. What is the equation for y-axis? What is the equation for y-axis? See, what is the equation for y-axis? I am asking equation for y-axis. X equal to 0 is equation for y-axis. Y equal to 0 is for equation for x-axis. Okay. So for y equal to y-axis, x equal to 0. That is degree Celsius equal to 0. When you put the intercept is 32. Okay. The height. This is the y-intercept. Okay. 32 is the y-intercept. Okay. So that means the line is dropping like this. Okay. So now you have to plot this line on a xy plane. You have to plot this model as a xy plane. Okay. So all of you note it down. Shall I move to the next topic? Shall I move to? So yesterday we discussed different ways to linear model a problem. Okay. So there are certain problems that can be modeled as linear mathematical equation. So what are the other? So there are different types of ways of expressing. Okay. So first one is y equal to mx plus c. Okay. So this is slope intercept form. Slope intercept form. Okay. So what is the equation for this linear model? So either way, the linear model. So having line, so it is going to intercept the x-axis or y-axis. Okay. So if it is intercepting the y-axis, at which point it is intercepting, you just check. So this is also equation. Okay. If it is horizontal. So if it is vertical, x equal to some value. Okay. So what is that value? So from the 0, how far it is. Okay. So that is the equation for vertical line. If it is a slanted one, so this is another way of expressing. Okay. So this is both intercept. So intercepting at the x-axis as well as y-axis. Okay. So what is the x-intercept? So it is having slope C3 by C2. C3 by C2. And the y-intercept C3 by C1. And this is x-intercept and this is y-intercept. That is C3 by C2. Okay. So if it is in this form, then the correct way of expressing is C1x plus C2y equal to C3. So this is another form of linear model. Okay. So please note it down, all of you. So next topic is linear interpolation. Okay. So linear interpolation. Okay. So this is an example problem. So what is meant by linear interpolation? So if you understand this problem, you can apply the linear interpolation. Okay. So what is given? So population of India in the year 2001 was 1 point. So population of India in the year 2001. Okay. So there is x-axis. So that is year, and this is population. Okay. So in the year 2001, we have data that is 1.029. Okay. 1.029 billion. So billion means what? Billion means 100 crore. Okay. So by the year 2011, okay, in between we have 10 years. So by the year 2011, so this is 2011. So what is the population now? 1.21. Okay. 21 billion. Okay. So this is first point, and this is the second point. So this value is 1.029, and this point is, this is 1.21. So population in billions. Okay, billion. Assume that the population growth was linear between these years. See, so it is a slightly a non-linear problem. Okay, so exactly it is not a linear problem. So that is why this assumption is coming. Assume that the population growth was linear between these years. Use linear interpolation to estimate the population of India in the year. So what they are asking? What they are asking? So they have given data for 2001. They have given data for 2011. What they are asking now? They are asking population at the year 2006. Okay. So at exactly 2006, what is the population? Now, how you can calculate? So this is by applying linear interpolation. So this problem can be solved by two ways. One is analytical, and one is graphical, and another one is analytical. Okay. So if you have graph, you can solve graphically by plotting. Okay. So if you want exact value, you need to calculate by analytical way. That is linear interpolation. Okay. So what is linear interpolation? Finding the in between points. See, we have data on the left, we have data on the right. We want data in the in between. Okay. Data in between. So in between may be at the exact center point, or it may be slightly leftward or slightly rightward. So the thing is, we have to calculate what is in between. So here or here or here, at any point, we have to calculate. Okay. So we have data here, we have data here. Now they are asking data here. Okay. So you calculate now what is population in the year 2006. Calculate. How you can calculate? You try to give solution for this. First, you have to calculate what is the difference between these two x-axis. Okay. So what is the difference? It is 2011 minus 2001. For the see, this is the change in x-axis. Okay. This is delta x. What is delta y corresponding? So for 2011 it is 1.21. For 2011 it is 1.029. Now calculate the difference. So 0.21 minus 0.029. So here 2011 minus 2001, it is 10. And at the top we have, so 0.21 minus 0.029. So what is the value? So what is the value coming? So we have to calculate the in between value. Okay. For that we have to calculate the difference between in the x-axis and the difference in the y-axis. What is the difference in the x-axis? 2011 minus 2001. That is 10 years. Okay. That is 10 years. In the x-axis, sorry, in the y-axis we have population. What is the highest value? 1.21. What is the minimal value? 1.029. Take calculator and calculate the difference. 1.21 minus 1.029. What is that value? So 1.21, 1.029. So 18. So 1.181. Sorry, 181 is not coming. So this is for 10 years. Okay. For 1 year, what is that value? 0.00181 for 1 year. For 5 year, 0.00181 into 5. This has to be added with a 1.029. Okay. So 1.029 plus 0.00181 into 5 is the value for population in the year 2006. Okay. At 2006. So now you calculate this value based on calculator. So next problem. So this is another application of linear interpolation. Okay. So they have given the height. Okay. They have given the height in the table under the corresponding density, air density. So from the ground, aeroplane has to fly. Okay. The air density is a variable. Okay. Continuously it is changing based on the height. That data is given already. Okay. So you calculate this. So not all the problems are following a linear trend. Okay. So in previous case, so we have a linear trend. Okay. So but here what we have? So we have a set of two equations. Okay. Set of two equations. So this is 2x plus 4y equal to 10. Okay. And this curve is 4x plus y equal to 6. So here our objective is to find the solution of this equation. Okay. So here if you see, so this line is 2x plus 4y equal to 10 and the dotted one is 4x plus y equal to 6. Both intersect at this point. Okay. So for this value, what is the x-axis? So it is 1. For this value, what is the corresponding y-axis? So graphically we can see here what is the value. But when you go analytical, so you can see for the value of x equal to 1, what is y value? It is 2 in both the case. Okay. So x equal to 1, y equal to 2. Okay. So that is the solution for this system of linear equation. Okay. All of you understand? Okay. We'll go next. So in previous cases, we discussed mostly equations involving line. Okay. So in practical scenario, not all the problems are linear by fashion. Okay. So all the problems are not linear. They are non-linear. So non-linear means it can follow, instead of this is linear one, this is linear. If it is non-linear, it may be like this, or it is like this, or it is like this. So all are possible non-linear problems. So non-linear means It is not a straight line. It is something different. It is following a curve or spline or anything. Okay. So this is example of nonlinear model. Okay. So one example nonlinear model. So it involves polynomial function. This is the laminar fluid velocity inside a pipe. Okay. So here u is a function of radius. Okay. So what is u? U is velocity. So what is r? It is a variable. It is radius. Okay. Radius at a given point. Okay. What is capital R? So radius of the pipe. For a given pipe, it is a constant. For a given pipe, it is a constant. What is V suffix C? It is center line velocity. Velocity at the center. That is VC. Okay. So velocity is a continuously varying phenomenon here inside a pipe. Okay. So likewise, the real problems exhibit nonlinear behavior. So not all problems are linear by fashion. Okay. So all of you noted. So capital R is radius of the given pipe. Okay. So which is a constant for a given pipe. Okay. So laminar flow. So there are two types of flow. One is laminar and another one is turbulent. So if the fluid are following a layer by layer movement, that is called a laminar. So if it is zigzag and random, then it is called a turbulent. Okay. So with respect to frictional point of view, laminar flow is preferable. So our human body follows laminar flow inside bloodstream. Okay. So when you plot this equation, you will have this kind of curve where the slope is continuously changing. So at each point, the slope is continuously changing. This is an important characteristic of nonlinear polynomial function. The slope is not a constant as we measured in linear equation, but it is continuously varying with respect to given point. Okay. So that is the important characteristic of nonlinear polynomial function. So here the calculation done. So next is stopping sight distance. So this is important one. So there are two vehicles moving. So like here they are mentioning. So this is vehicle number 1 and this is so when there is some incident happening. So when you observe that incident, how much time it will take to react for you to react. So that is the stopping sight distance. Okay. So it is a model known as stopping sight distance used by civil engineers to design roadways. So this simple model estimates distance a driver needs in order to stop his car while traveling at a certain speed after detecting a hazard. Okay. So if you are riding in a road, if there is some accident, then you need some distance to react. Okay. So that distance is called a stopping sight distance. Okay. So this is used by the civil engineer to calculate the to restrict the velocity. So sometimes in the road you may seen velocity boards. Okay, the speed boards. Okay, so how they calculated it is based on the stopping sight distance. Okay, so based on the road condition they measured it and they fixed the value. Okay, so the equation is S equal to V square divided by 2G F plus or minus G plus TV. Okay. So what is the meaning? S is stopping sight distance. V is initial speed, the speed at which you are going. Okay. So this is initial speed and this is final speed. So what is G? Acceleration due to gravity. Okay. What is F? Coefficient of friction between tire and a road. So which is a varying one. Okay. What is G? Grade of road. Okay. And T is driver reaction time. When you have a road with lesser friction, what happens then? You will need more reaction time. You will need more reaction time. If you are riding at very high velocity, then what happens? Then you will need stopping side distance very high. Okay. If velocity velocity is proportional to, so stopping side distance is proportional to v square. If v is very high, then s also become very high. Okay. So that is why the people are saying don't go at very high speed, because you don't have much stopping side distance. Okay. Please note it down. So this is the problem. You try to substitute these values and calculate what is stopping side distance. Okay. So today we are going to discuss deflection of beam. Okay. So you might have already explored different types of beam, different type of support. So what is this type of beam? What is this type of beam? The deflection of a cantilever beam is an example nonlinear problem. Okay, so it involves higher order polynomial. Okay, so second order. So for example, the cantilever beam here it is shown. So initially, what is the deflection here? So at this point, if you measure at x equal to 0, what is the deflection? Corresponding deflection? Y also 0. Why? When you substitute this value x equal to 0 here, x equal to 0. See, you prepare a table like previous class. X, sorry, this is 0. So this is x value, this is y value. 0, 1, 2, 3. So when x is 0, what is value of y? So you substitute 0 here. 0 square minus 4 into 0 plus 6l square. Okay. So 6l square. So again here we have x equal to 0 minus w into 0. Anything multiplied by 0, it automatically becomes 0. Okay. So what is the value coming here? It is 0. So since it is fixed one, there is no deflection measured here at this point. So this is the point where x equal to 0. What is y? Y is deflection. Y is deflection. What is w? It is uniformly distributed load. Uniformly distributed load. Okay. So since even though it is a uniformly distributed load, the deflection is not going to be like this, but the deflection as we progress in the x direction, it is more or like looking like this. Okay. It is following a linear or non-linear. It is a linear trend or non-linear trend. Okay, it is not a linear one. It follows a curved path. When it is following non-linear, that is curved path, that is a non-linear model. Okay, so this is an example model for non-linear problem. This is a non-linear problem. Likewise, when you take engineering, so every problem, most of the problems are non-linear by nature. Very simple problems are linear by nature. Most of the problems we end up with will be having non-linear nature. Say for example, if you take your bone, so bone has more porosity. Okay, bone has highly porous in nature. Okay, so in between we have air cavity. Okay, so the material is based on calcium. Inside we have varying porosity. Okay, inside we have varying porosity. So at the outer portion we have more density of material. At the inner portion we have more air gap. Okay, so the density is not a constant here, it is continuously varying. If you plot the density versus distance, rho versus distance, it is like more or like here. like this. Okay, as the density increases, distance increases from the left side to right side. So on the left side it is the density is very high. On the right side also density high, but at the center density is somewhat lower, relatively lower. Okay, so this is an example, another example for nonlinear model. So in nature, most of the problems are nonlinear nature. Okay, so now your task is to plot the deflection equation in the xy graph. Okay, so use this table. Calculate what is y for x equal to 1. When x equal to 1, what is y value? You calculate. So y is the deflection, W is the distributed load intensity, that is W is measured in newtons per meter. For each meter, what is the load? So what is E? Elastic modulus of elasticity. Okay. So what is modulus of elasticity? So modulus of elasticity, shear modulus, and the bulk modulus. These are three different properties of material. Okay. Mechanical properties of material. So this is I is second moment of inertia measured in meter per 4. X is distance from the support. From the left side, what is the distance? That is nothing but your x. Okay. This is the support. So that is the support. L is the total length of the beam. Okay. So L is total length of the beam, that is also measured in meter. So now you calculate, this is the problem. You take this as the problem. So length of the given beam is 5 meters. Okay. Length of the beam is 5 meter with the E value 200 GPa. Okay. 200 gigapascal. What is giga? Giga is 10 power 9. Okay. What is Pascal? What is the expansion for Pascal? Newton per meter square. Okay. What is I? 99.1 into 10 power 6 millimeter power 4. So now the problem, if you see the problem, it is given in meters. This is also given in meter, but this is given in millimeter. You have to convert into meter. Next, load intensity given in Newton per meter. Either you convert everything into meter, or you convert all the remaining units into millimeter. So either way you have to go. Okay. So likewise, so you have to go. So to plot, we have to have x value and the corresponding y value. So we have to calculate. So by feeding x value 0, 0.2, 0.4 like that. So we have to input these values in the equation, in the deflection equation. So the deflection equation y equal to minus w x square divided by 24 ei into x square minus 4l x plus 6l square. So this is the deflection equation where x value is changing. Okay. So x value is changing from 0, 0.2, 0.4, 0.6, 0.8 like that. Okay. So what is the other value? Length of the beam. So it is given in the problem. What is the length? What is L value? What is the length of the beam? So what is the length of the beam? That is inertia. What is length? Length of the beam. Length of the beam is 5 meter. Next, what is E? E is Young's modulus. Young's modulus of the beam. Okay. What is the Young's modulus of the beam? What is the value? Capital E. 200 gigapascal. Okay. So to gigapascal, we have to convert it into SI unit. What is the SI unit? Correspondingly, 200 into what is giga? What is giga means? So what is giga means? 10 power 9 into 1 Pascal equal to 1 Newton per meter square. Okay. So this is second value, given value. Third given value is W is given already, right? What is W? Loading rate. 1000 Newton per. So 10,000 Newton per meter. 10,000 Newton per meter. What is the next given value? I. What is I? 99.1 into 10 to the power 6 millimeter power 4. So this is only in millimeter power 4. So the convenient is convert this millimeter power 4 into meter power 4. Okay, convert this millimeter power 4 into meter power 4. What we have to do? What we have to do to convert a millimeter power 4 into meter power 4? So everything you convert everything into meter. So this value is meter, this value is in meter, and this is in meter. The only difference is this is in millimeter power 4. Convert millimeter power 4 into meter power 4. Okay. So milli means 10 power minus 3. Power 4. It becomes 4 into minus 3 becomes 12. So it is 10 power minus 12. Multiply this 10 power 6 into 10 power minus 12. It becomes 10 power minus 6 meter power 4. 99.1 into 10 power minus 6 meter power 4. Like that, if you substitute all the values, I value is there, loading rate W is there, and E is there, and L is there. All the variables are given. X is continuously changing. X starts from 0, it's moved to 0.2, move 0.2, move 0.4. So when you convert, when you put all these values in this equation, you can arrive at the Y values like this. Okay. So this is Y value for each X value. When you plot in a XY plane, you will come up with a curve like this. Okay. So this is the deflection. So deflection at X equal to 0. What is the deflection value? It is 0. When the value is increasing along X direction, the deflection is also increasing along the negative Y axis. Okay. Why? Because of the load, increase of load. So every meter 10,000 Newton is increasing. What is the 10,000 Newton? It is around 1000 kilogram. So for a meter, for each meter 1000 kilogram of load is increasing. So in the first meter 1000 kilogram will be applied. In the second meter 2000 kilogram will be applied. Likewise, the load is increasing every meter. What happens at the end? The deflection will be more because of the increasing magnitude of the load. Okay. So that is why the deflection is increasing in this direction. Okay. With respect to distance. Okay. So this is about deflection of cantilever beam. Next topic. So when you see, first we deal with the y equal to mx plus c, that is linear equation. So x power only 1. When we move to higher order polynomial equation, not only we have a0 plus a1x, that is nothing but this is constant and this is slope and corresponding power 1. So this is power 2, this is power 3. So these are, when we have more powers of x, this is called polynomial equation. When we have more power of more than power 1, it is called a polynomial equation of. Okay. So this is higher order. So when we go for higher order polynomials, the slope is continuously changing. That is the key understanding. When we have this equation, the slope is constant. Slope is constant. But when you go for higher order polynomial, slope is variable. Continuously changing with respect to x axis, x values. Okay. All of you understand? So an example is, so take this as equation, example equation. Okay. So this is y. This is y. What is y? Y is a function of x. When we have a change in x, there is a change in y. Okay. What is the equation? It involves x power 3 minus 6x square plus 3x plus 10. When you plot, we have arrived at a when you have plot this value, so we will arrive at this kind of curve, okay, where the slope is continuously changing. Here it is different, here it is different, here also it is different. For each x value, the slope is continuously changing. So this is the key characteristics of higher order polynomial equation, okay. So how we can plot this curve? So for again same, repeating the same. So find the x value. So next find the corresponding y value. So x value is -3, -2, -1, like that. You take 0 at equal intervals. You have to take, okay. So you have to plot this graph. So similarly, these are an example of higher order polynomial equation, okay. Similarly, the second example equation is x square plus 4. So we have y equal to mx plus c. That is a straight line. So y equal to mx plus c is a straight line. So the slope is constant throughout. Here also same slope. Here also same slope. But when you go for higher order, slightly higher order polynomial like x square plus 4, here the slope is changing. Here the slope is changing. Similarly, the slope is changing here with respect to each point. That is the key understanding. Okay. All of you understand? So next model we are going to see is exponential and a logarithmic models. Exponential and a logarithmic models. So in this model, if you take a bar, okay, like this, you heat uniformly. You heat, okay. So when you expose to the environment, so you heat up to 1000 degrees Celsius, okay. For example, so in this problem, so already some values are given, okay. So what is the first value? K. So K is the first value. K equal to 40 watts per meter Kelvin. Okay. So next density of the material is given. Density is 7800 kilogram per meter cube. Okay. So specific heat C is given 400 joules per kilogram Kelvin. Okay. So this plate is heated up to temperature value of 900 degrees Celsius. What is T initial? So T initial is 900. So the plate is heated and reached a value of 900 degrees Celsius when it is exposed to the air. That is the initial value, first second when it is exposed to the air. Okay, at that time what is the temperature? That is the T initial. Okay, don't confuse. While heating, it is a lower temperature, it is gradually increasing. It is not like that. Okay, when it is exposed to the environment, that is air, what is the temperature? 900. Gradually it is keep on reducing. Okay, so that means that is the first temperature is 900. Okay, on the left hand side you can see that is the first temperature, that is T initial. Okay, so next T environment. What is T environment? What is T environment? 35 degree Celsius. Okay, next what is heat transfer coefficient? H equal to 25 watt per meter square Kelvin. Next, what is the length of the plate, steel plate? What is the length of the steel plate? So it is 5 centimeters. So the problem is they have taken a 5 centimeter plate. Okay, so the length is 5 centimeter and put it inside a oven so that the temperature is increasing up to 900 degrees Celsius. Okay, so what happens then? They make it So L is 5 centimeter. Okay. So now what is the model? So model of the equation. So T minus T environ divided by T initial minus T environment equal to exponential of minus 2h divided by rho CL multiplied by T. What is T? Time. So time is measured here as 0th second and 0.2. Sorry, it is measured in hours. So it is 0, 0.2 hour, 0.4 hour, 0.6 hour. Similarly, it is going like, okay. So we have to substitute here. Okay. So what is T? T is an unknown. So that is what we are finding here. Okay. What is T? That is the unknown that we are calculating. So T is a variable that we are calculating minus T environment. What is T environment? 35 divide by what is T initial? 900 minus what is T environment? Again it is 35. Okay. Equal to exponential of minus 2h. What is h? Minus 2 into h 25. Okay. 25 divide by. So into T. What is T? Time. So initially first value is 0, next value is 0.2, third value is 0.4. It is keep on increasing like that. So for each value of T, so what is T? T is an unknown. T is not an unknown, so it is a variable. So it is keep on changing. Okay. So 0, 0.2 hour, 0.4 hour. We have to substitute for each value and calculate what is what. Okay. Next, what is rho? Rho for the steel is 7,800 multiplied by what is next value? C. C is 400 multiplied by L. What is L? L is given 5 centimeter. So centimeter has to be converted into meter. Okay. 5 centimeter. 5 into 10 power minus 2. So this is the equation. So use your calculator or Excel sheet. Okay. Use your calculator or Excel sheet and plug in T values and calculate what is capital T. Okay. So plug in small t values as 0, 0.2, 0.4, 0.6 like that. Now calculate what is capital T, temperature value. Okay. All of you understand? So what is unknown? T is an unknown. T is capital T, temperature is unknown. This is known. Okay. Understand? So like that, if you plot, you will arrive at these kind of values. Okay. When you combine all the dots, it will give you a curve. That is what exponential curve. That is what we call it as exponential curve. Why? Here you can see from 0 to 1 there is a rapid decrease of temperature, but 1 to 2 there is slight reduction in the speed of reduction of temperature. From 2 to 3 again the temperature drop is very minimal. Similarly 3 to 4 again relatively minimal. See, when you compare 4 to 5, what is the difference? Very negligible. But when you see here from 0 to 1, the difference is rapid. The difference is rapid. So this is the characteristic of exponential model. Okay. This is the characteristic of exponential model. Okay. So you take your Excel and plot it and plot this curve. Okay. So this is assessment. Next. Okay. So what is one model is exponential, another one is logarithmic model. Okay. So exponential, usually people use E, or in calculator you can find this kind of symbol exp, or in programming they use exp. Okay. So e power x or exponential of x, both are same. So what is E? E has certain value. E has certain value. It is nearer to 2.714 kind of. Okay. So So this is the exact value. So what is the meaning? So if you take n and 1 plus 1 by n whole power n. So when you put 1, what happens? 1 plus 1 by 1 whole power 1. It becomes 2. Okay. When the value of n is 2, what happens? So 1 plus 1 by 2 whole power 2. So 1 by 2 is 0.5. 1 plus 0.5 becomes 1.5. 1.5 power 2. 1.5 into 1.5 becomes 1.25. Okay. So that is what here they find. Okay. So 1 point. So sorry. 1.5 into 1.5. Sorry. What is 1.5 into 1.5? So 1.5 into 1, that is 1.5. 1.5 into 0.5 is 0.75. 1.5 plus 0.75 becomes 2.25. Okay. So this value is 2.25. Okay. So this value is 2.25. Like that, if you increase the n value, it reaches a value. When n goes to infinity, when n reaches infinity, the value of E becomes, it is reaching 2.71828. Okay. So it is reaching a value of this value. So when you reaching the higher value, we can exactly find what is E. What is E? So that is based on the computing power. When you have more computing ability, we can more exactly find out what is the exact value of exponential. Similar to pi. So pi, what is happening to pi? People are finding more appropriate method for value of pi. Okay. So when you go to logarithmic models, so we are using logarithmic functions while dealing with a large value. So when we use the, so two kind of logarithmic scale is there. One is log, another one is ln. So what is the difference between log and ln? Log is having base 8, base is 10. Okay, base is, log is having base 10, ln is having base E. Okay. So what is log? It is base 10. Okay. What is ln? It is base E. What is value of E? Just before we said 2.718. Okay. It is going like this. Okay. So why we use logarithmic functions? To reduce, when we are dealing with a larger values, we are using log or ln. Okay. So that is the idea. So another thing, log xy will be equal to log x plus y. These are you already studied in 10th standard. Log x by y will be equal to log x minus log y. Similarly, log x power n equal to n into log x. Okay. So these are some fundamental values, equations. So next, decibel scale. Okay. So our human ear can notice this much amount of smaller sound pressure. Okay. So what is sound actually? So sound, when we are speaking, we are inducing a pressure difference, a minor pressure difference. Okay. So this pressure is P1 and this pressure is P2. There is some difference between P1 and P2. So this is moving like a wave. This is moving like a wave at 330 meters per second. That is the speed of the sound wave. Okay. So when I am speaking, what happens? There is a pressure difference induced in the air, that is traveling like a wave. Okay, that is traveling like a wave. Okay. So what is the least magnitude of hearing? That pressure is 20 into 10 power minus 6 Pascal. Okay. What is the maximum? 20 into 10 power 6 Pascal. So this is the least value. This is the maximum that we can hear. Okay. What is Pascal? It is measured in Newton per meter square. Okay. So that is nothing but pressure. So there is pressure difference induced while transferring the sound from one location to the other location. Okay, so that pressure difference is 10 power 10 power 20 into 10 power minus 6 Pascal, means it is the least amount of sound that our ear can sense. Okay, so when the pressure is magnitude is increasing, like it is going to 20 into 10 power 6 Pascal, then it is the maximum value that we can hear, beyond which we cannot hear, or it damages our eardrum. Okay, so from that only they are plotting the decibel scale. So okay, so what is the least value? This is 20 into 10 power minus 6 Pascal. Okay, what is the maximum? This is 20 into 10 power 6, that is the maximum. Okay, so from here you can see, so this is 100 millipascal, means the birds sound of the birds is coming around 100. Okay, so office environment it is around 1000. Okay, car 10,000 in 1 lakh into 1 lakh millipascal. So like that it is going. Now, how the decibel scale is defined? It is defined by a formula, 20 log I by 20 micropascal. What is I? That is the environmental sound pressure. Okay, from using this formula we can find a value, that is the decibel. That is the decibel. Okay, so this is all about decibel scale. Okay, next, so apart from that, these are some useful functions, mathematical functions you can apply. Okay, you go through that. So next topic is simultaneous linear equation. Solution of simultaneous linear equation. So example is, say for example, 3x plus 4y plus z equal to 5. 2x plus 3y plus 2z equal to 10. 5x plus 4y plus z equal to 7. So the first method for solving simultaneous linear equation. Okay, so first method is Gauss elimination method. Okay, so Gauss elimination method by, so we have three variables. So in the example problem we have three variables, three equations. Okay, so to solve a three equation involving three variable, we can have three solutions. We can have three roots for three different variables. Okay, so that is the idea. So Gauss elimination method eliminates first x1, then x2, then finally find the x3. Okay, so that is the idea. So here we have to eliminate by equations. Okay, so first three equations we have to take first two equations, then we have to take remaining two equation. So first I am going to eliminate x1 from these equations and then x1 from these two set of equations. Okay, so first step 1. So divide by 2 the first equation. So it becomes x1 plus x2 divide by 2 plus x3 divide by 2 equal to 13 divide by. So this is the simultaneous equation we have to solve. Okay, so this is first equation number 1, 2, and this is 3. Okay, so let's focus on removing equating the x1 terms for equation 1 and equation 2. So equation 1 has 2x1, whereas equation 2 has 3x1. So first I am taking equation 1. Okay, so 2x1 plus x2 plus x3 equal 13. Okay, so that is equation 1. So to convert this 2 portion into 3, what we have to do? We have to divide by 2 and multiply by 3. Okay, so that is the step I am going to do. Now I am going to divide by 2 the equation number 1. Okay, so that is the idea. So when you divide by 2, the above equation will become, so x1 plus 1 by 2 x2 plus 1 by 3 x3 equal to 13 divided by 2. So that is the step 1. Okay, that is step 1. Okay, so next, so what is the next step? Step 2. So now I am going to multiply, since we have to equate the equation 1, the x1 value nearby numerical value to 3x1. Okay, so because it is there in equation 2. Okay, so our task is to equate x1 terms equal value. Okay, so here in equation 1 and equation 2. So what I am going to do now, I have to multiply by 3. I have to multiply by 3 equation 1. Okay, so when I am multiply this modified equation. Okay, so this is modified equation 1. Okay, so if I multiply by 3, what will happen? So 3x1 plus 3 by 2 x2 plus next, so 3 by, sorry, here 2. Okay, so 3 by 2 x3, which is equal to, here we have 13 on the 13 by 2. Previously we have 13 by 2. When we multiply the 13 with respect to 3, it is 3 into 13, it becomes 39. 39 divided by 2. All of you understand so far? Okay. So this is step 2. So what I did here, so I am equate the x1 values, nearby values in both the equation 1 and 2. So that is the idea. So everyone clear? Noted? Now I have to move to next slide. Now we have to subtract the modified equation 1 to equation 2. Okay, what is the modified equation? So what is the equation 2? 3x1 plus 2x2 plus 4x3. Okay, 32. So that is equation 2. Okay, so we have to subtract the modified equation from equation 2. So what is the modified equation? 3x1 plus 3 by 2x2 plus 3 by 2x3 equal to 39 divided by 2. We have to subtract. So 3x1 minus 3x1, 0. Okay. Next, 2x2 minus 3 by 2 x2. So what is, here we have 2 minus 3 by 2. What is 3 by 2? 2 minus 1.5. Okay. 2 minus 1.5. So it is 0.5. That is nothing but 1 by 2. 0.5 can be written as 1 by 2. 1 by 2 x2 plus 4 minus 3 by 2 x3. What is 4? So 4 as it is minus 3 by 2. What is 3 by 2? Minus 1.5. Okay. So 3 by 2 is 1.5. 4 minus 1.5. 2.5. 2.5 plus 1.5 becomes 4. Okay. So 2.5 can be written as 5 by 2. Okay. So 5 by 2 x3 equal to 32 minus 39 by 2. So what is 39 by 2? 19.5. 5. Okay. So 0.5 to 12.5. 12.5 can be written as 25 by 2. Okay. Understand? So this is the end of step 2. Okay. Please note it down. All of you finish the copying. So now next step 3. So what is step 3? So in the first step 1, if you carefully note down the equation, that is x1 plus 1 by 2 x2 plus 1 by 2 x3 equal to 13 by 2. So this is the modified equation for the equation 1. Okay, available in the step 1. Now take that equation. Okay, so we have to now focus on the third equation. What is third equation? So third equation 3 is 5x1 minus x2 plus 3x3 equal to 17. We have already divided and ready. The x1 is ready now. Okay, simply we have to multiply this x1 with 5. That's the task. Okay, if we multiply the x1 by 5, what will happen? We have 5x1 in the above top equation, we have 5x1 in the bottom equation also, so that the cancellation will be easy. Okay, so that's what I am going to do. I am going to multiply. So we have to multiply the. So I am going to multiply by 5. Okay, so that is the step 3. Multiply by 5. So this equation multiply by 5, it becomes 5x1 plus 5 by 2 x2 plus 5 by 2 x3 equal to, so 13 into 5. What is the 13 into 5? 65 divided by 2. So now if you look into the equation, these two terms have 5. Okay, the magnitude is 5. Okay, so that we can easily subtract and get rid of x1. Okay, so that is the idea. So now we have to subtract these two equations. So subtract this equation from this equation. Okay, so now subtract. So 5x1 minus 5x1, 5x1 minus 5x1, 0. Okay, 0. Next, minus x2. Okay, so we have minus 1 minus 5 by 2. So 2 into minus 1 minus 2 minus 2 minus 5 becomes minus 7 by 2. Minus 7 divided by 2 x2. Then 3x, we have 3x3 minus 5 by 2. So 3 minus 1.5. So 3 minus 1.5, obviously 1.5. Okay, sorry, 5 by 2 is 2.5. 3 minus 2.5 is 0.5. So what is 0.5? 0.5 can be written as 1 by 2. Okay, So plus 1 divided by 2 x3 equal to, similarly, you calculate for 17 minus 65 by 2. What is 65 by 2? 2 3s are 6, 2 2s are 432.5. So 0.5, 4, okay, 17 plus 14, 30, 31.5, 17 plus 5, 15.5, 15.5, okay, can be written as, so it is minus 15.5, okay, since this value is higher, minus 15.5, minus 15.5 can be written as minus 31 by 2, okay, all of you understand so far? So now we have two equations, involving two variables, okay, so involving two variables, that is the idea. So now I'm going to summarize the results. 1 by 2 x2 plus 5 by 2 x3 equal to 25 by 2. Next equation is minus 7 by 2 x2 plus 1 by 2 x3 equal to minus 31 divided by 2. Okay. So this is the end of step 3. Okay. So all please note it down. Now the step 4. Okay. So now what is step 4? I'm going to I need to have these two values same. Okay. So what I can do, I just multiply the first equation by 7. So why I am keeping 7 as a positive value is because we have minus 7 by 2 here. When we add, then automatically these two will get cancelled. Okay. So I am just multiply this equation by 7. Okay. So that is the step 4. Now we have 7 by 2 x2 plus 7 5s are 35 by 2 x3 equal to 25 by 2 into 7, 175. So 175 divided by 2. Okay. Here we have minus 7 by 2 x2 plus 1 by 2 x3, which is equal to minus 31 divided by 2. So we simply add both the things, will the x2 get cancelled. Okay. When you add simply, so what is the result? 35 by 2 plus 1 by 2. Okay. So 36 divided by 2 becomes 18. Now we have 18 x3 equal to, so we have 175 minus 31. Okay. So 175 by 2 minus 31 divided by 2. So which is equal to 2. So 473 4 144. Okay. 144 divided by 2 becomes 72. So this value 72. So 18x3 equal to 72. Then x3 is, then what is the value of x3? So x3 is 4. Okay. So that is the end of step 4. Okay. So next step, step 5. So now we move to step 5. Okay. So what is step 5? So we have to plug the x3 value in the first equation. What is first equation? X2. Okay. X2 plus 5x 5x3 equal to 25. Now, so what is the value we found out? X3 already we found out. What is X3? It is 4. X2 plus 5 into 4 equal to 25. Now, X2 plus 5 into 4 becomes 20 equal to 25. X2 it becomes 25 minus 20. It is 5. Okay. So, X2 is 5. Now, plug this value in the equation 1. What is equation? That first equation. Okay, that modified first equation, x1 plus 1 by 2. What is x2? X2 is 5 plus 1 by 2 x3. What is x3? It is 4, which is equal to 13 divided by 2. Now what is x1? x1 plus 5 by 2 plus 4 by 2. That is 4 by 2 equal to 13 by 2. So 5 plus 4 is 13. Sorry, 5 plus 4 is 9. 9 by 2. So keep move it on to the right hand side. So it becomes minus 13 minus 9 by 2. Okay, 13 minus 9. Okay, this is equal to 13 minus 9. So 9. So we have 4 by 2. Finally, x1 equal to 4 by 2 is 2. Okay. So x1 is 2. Now, what is the results? What are the results? So what are the results? X1, X2, X3. What is X1 value? 2. What is X2 value? 5. X3 is 4. Okay. So this is answer for the problem. So this is how you have to execute the Gauss-Seidel method for solving the simultaneous equations. Okay. All of you understand. Next we move on to calculus. Okay. Now if you see what is the definition for derivative. Okay. So we are going to see some terms relevant to differential and integral calculus, and we try to solve some simple problems. Okay. So first one, what is the this is the definition for derivative. Okay. So we have a function f of x. Okay. When you differentiate, it becomes f dash of x. Okay. So we just differentiate. Okay. What is differentiation? We simply divide. Okay. We simply divide them. So for example, so a bus is traveling from one location to the other location. Okay. So one location to the other location. Okay. So at each time, if for each time frame we are dividing. So this is somewhat relevant to differentiation. Okay. So how the value become accurate, more and more accurate when we divide the intervals more and more minimum. Okay. Minimum towards 0. Okay. So that is what here it is mentioned. H is the difference between each frame. Okay. When we have very lesser value, this value, then automatically the differentiation value will be accurate, more enough. Okay. When we have less, when the interval is very wider, then we have very less accurate results. Okay. So what is the now definition for differentiation? Limit h tends to 0, f of x plus h minus f of x divided by h. Okay. So what is f of x plus x? Say at this point, 0th second, this is the velocity, 3 meter per second is the velocity. At the first second, what is the velocity? 5 meter per second. That is the velocity. What is the x plus x h? This is f x plus h. What is f of x? This is f of x. So what is h? In between we have 1 second. that is h. Okay. So h tends to 0 means what? When we reduce this value 1 second to microsecond, then we have better, more accurate result. When we reduce nanoseconds, we have furthermore accurate results. So accuracy depends on how minimal interval we are measuring. Okay. So that is the idea for this. Next, if f of x is constant, then f dash of x is 0. What is that meaning? Say, for example, in that bus problem, so the velocity is constant. Is there any so at each hour the bus is going to travel a constant amount of distance? Okay. So if velocity is kept as 10 kilometer per hour, for example, for this bus. So in the first hour it travels 10 kilometers. In the hour 2, how much it will travel? It will definitely travel another 10 kilometers. In the third hour, when it completes third hour, again it travels another 10 kilometers. Okay, the velocity is constant. There is no change. There is no change in the distance traveled. That means velocity is now kept as constant. Okay. Okay, change in distance. What is the change in distance? Either it is increasing or decreasing. Rate of change. So initially it is 10 kilometers. After some time it is 10 kilometers. After some time it is also same 10 kilometers. When you subtract the 10 kilometer from 10 kilometer, what is the change now? What is rate of change? 10 minus 10 is 0. So that is what here value coming. So why it is coming? We have to understand f dash of x, why it is become 0 when the f of x value is constant. This is how it is 0. Okay. Next, f of x is x plus x power n. Then when we differentiate, it becomes n into x power n minus 1. These things you already know, some simple definitions. When you have constant multiplied, a is a constant. You can keep the constant out of differentiation. So that is the term for 4, definition for 4. Then if f of x is a combination of g and h, then we can simply differentiate both the terms separately. Okay. So that is so next term is, so when two functions are in multiplication, then this rule is not applicable. This is not applicable here. Okay. So we have to follow this rule, UV rule. Okay. So what is UV? When we differentiate UV, what happens? U dV or UV dash plus V U dash. Okay. So this is how you have to follow. So this is what we call it as product rule. Okay. Next, quotient rule. Similarly, when two functions are in division, then in that time when we try to differentiate, we have to follow this rule. Okay. So this is the idea. These things already you know. So if f of x is equal to f of g of x, it is a function of another function called g, which is equal to f of u, where u is called g of x. So f dash of x becomes df of x divided by du into du by dx. We can rewrite like this. Okay. So next, so these are some definitions you go through. So if it is ln of g of x, what happens? So you have to differentiate the inner portion g dash of x. So initially it is g of x and you have to divide by the original equation. This is when the function is ln. Okay, sorry, ln of absolute function of x. Okay. So e power x becomes e power x. So that is the key idea. When you differentiate e power x, it becomes e power x again. No change. Okay. But when you have constants in that power, that when that time we have to differentiate this term and multiply that value here. Okay. So that is the idea. So all please note it down. Next. So some example problem. See, f of x is x cube minus 10x square plus 8. Find the derivative. What is derivative? F dash of x. Now you say you are going to answer. When we differentiate the x cube, what is the value? 3x square minus 10 into x square becomes 2x. Okay, 2x into 10 becomes 20x plus 8 becomes 0. Okay, so these things you know already. 3x square minus 20x. This is f dash of x. Similarly, 5x cube. Similarly, you just need to multiply 5x cube minus 50x square plus 40. Okay, so this 40 goes to 0. F dash of x. So 3 into x square. 5 3s are 15. X square minus 100x plus 0. Okay, so that is the thing. So this is another slightly trickier. So either you can approach this problem like UV method. What is the UV method? UV, you have to differentiate. It becomes UV dash plus V U dash, which is VU dash. Okay. So first make it U as it is, x cube minus 10 x square plus 8 into V dash. What is V dash now? 5x power 4 minus 5 plus V. What is V? X power 5 minus 5x into what is U dash? Now 3x square minus 20x. You just simply multiply. Okay, multiply and add. So that is f dash of x. Okay, I am leaving it to you. So next, ln of x cube minus 10x square plus 8. What is f dash of x? So 3x square minus 20x plus 0 divided by x cube minus 10x square plus 8. Okay, understand? So similarly, integral calculus, these things also you already very well know about these things. So integral of a dx becomes ax, x power n becomes 1 by n plus 1 power x power x power n plus 1 divided by n plus 1. So there is a addition of 0 in every term. So that is why that 0 becomes now when we integrate, that is the opposition of differentiation. Okay. So when you integrate the 0, there is a constant value added. This constant you have to find out by applying some boundary condition. Okay. So you check these terms also. Now you integrate 3x square minus 20x. 3x cube by 3. Okay. Integral. Okay. When you integrate minus 20x square divided by 2 plus constant. Okay. So 3 get cancelled. It becomes 10. Finally, what happens? X cube minus 10x square plus c. So that is integrated value. Similarly, you apply UV method for here. Here it is in addition. Okay. So it is in simple addition. We just integrate separately these two terms. Okay. So integrate 3x cube by 3 minus 20x square by 2 plus or minus 5x power 5 by 5 minus 5x. Finally, we have plus c. That is, you have to remember now x cube minus 10x square plus or minus x power 5 minus 5x. Okay, plus c. Okay. Next, next remaining. So this UV method again. Okay. So you calculate based on UV method. So what is that value?